decreasing, and those pieces. So you've already determined these characteristics about this graph. Very good job. We now want to examine the increasing, decreasing concavity, local min, local max, inflection, and all of that stuff. So we have a little bit more complicated function than we dealt with yesterday. And what's really cool is that you have no idea what it looks like. So on your assignment that I gave you yesterday, there's 8 problems. You only have to do the first 6. Okay? If you did not come back to get the assignment yesterday, I'll give it to you today. But you only have to do the first 6. I would encourage you to do the last 2, but if you don't want to, that's fine. If you get an x cubed, do you have a general idea of what the x cubed function looks like? Yeah, but what's neat about this is you really don't know what 2x squared over x squared minus 1 looks like. So let's truly take an investigative approach. We've got a good start here, but we got room to grow. F prime of x is equal to, what rule do I use? Quotient, derivative of the top, 4x times minus over x squared minus 1 squared. Quotient rule. We all good with that? All right. So I've got 4x cubed minus 4x minus 4x cubed. Yeah? Divided by x squared minus 1 quantity squared. So that means in the top, the 4x cubes cancel. I get negative 4x over x squared minus 1 quantity squared. We all good? Okay, so I'm going to check the first derivative test here. I'm going to use a number line. I'm going to show you a very easy way to work through this, and I'll show you just a little bit more complicated way. What up? Do you know what this looks like? You don't. If you know what the graph looks like, then graph it. That's easier, right? It's quicker. But I'll also show you a quick way to work through this one. You could. You could. Yep, without a doubt. So I'm going to show you how you can do it even quicker without plugging your calculator. But without a doubt, you may end up with the situation in the AP exam as they say, this is the first derivative, no calculator. How do you determine where it's increasing or decreasing? Okay? So I need to check 0. What else do I need to check? 1 and negative 1. Tell me something about the denominator. It's always positive. So the denominator doesn't really have any bearing on the change of sign at all, does it? It's simply just the numerator. If I punch in a negative times a negative will give me a positive. If I type in a positive, a negative times a positive, negative times a positive will give me a negative. See how quickly I did that? Part of that is just recognizing that the bottom is always positive because it's being squared. The top is negative times a negative or negative times a positive, and that's what you need to take in consideration. Now, if you didn't like that, you could just go ahead and type in negative 2, and you get positive 8 over 4 minus 1 is 3, 3 squared is 9, and see that that's positive. You could plug in each value, or you could recognize that. Are we all clear? What the heck does that tell us? So increasing from negative infinity to negative 1, union with negative 1 to 0. Decreasing from 0 to 1, union with 1 to infinity. So first derivative tells us about increasing, decreasing. What else does it tell us about? Local min and local max. So the local max occurs when f prime changes from positive to negative, and min occurs where f prime changes from negative to positive. Do I have either of those situations that exist here? I have a local max. Now be careful, folks. Are all these points in the domain? What points are not in the domain? -1 and +1. So is 0 in the domain? Yes, it is. So therefore, I can include it as at local max point. It happens at a value of 0. Is there a local min? There is not a local min. Okay? Excellent. How would I then achieve the y value? How would I get the y value? Plug it into the original. If you plug 0 into that guy, you get 0. Great. We already have a majority of this information figured out. How do I do the rest? Second derivative. Oh, boy. Well, we could do that one thing, or... Yeah, you know, it's a horse apiece in this situation. I would actually choose to use the quotient rule. I know I had a professor in college said he never used the quotient rule. He would always use the product rule with the chain rule. And he would just bring this up and make it a -2. I actually don't care for that in the way that the simplifying occurs. If you commit to that process every time you do them, then that's different. But hey, it's America, free country, do what you want. All right, so here's where we go. F double prime, derivative of the top, times the x squared minus 1 quantity squared minus the top, so plus 4x, times the derivative of the bottom. Very good. Okay, so D. Weiland sees it very quickly. We'll spell it out for everybody. He used the chain rule. He said u squared and x squared minus 1. And in his brain, he said the derivative of the inside was 2x, and the derivative of the outside was 2u. He multiplied them together to get 4x times u, which is x squared minus 1. All over what? X squared minus 1 to the 4th power. Now, some people might wonder, well, why don't you want to multiply that 4x through there? Well, because we've done this enough times where we can anticipate that there's going to be some canceling, right? So what cancels? Yeah, you got to get rid of the factors of x squared minus 1. So this is going to reduce to the 1st power. This is going to reduce to the 3rd power. And now we could go through some simplifying. So therefore, f double prime of x, what that tells us is we have, oh boy, negative 4x squared plus 4 plus 16x squared all over so f double prime of x is equal to 12x squared plus 4 over x squared minus 1 cubed. Ooh. It's up to you. I don't really want to. Tell me something. Notice something. Top's always positive. So does top have any bearing on the change of sign of this function? No, it's always positive. We can really ignore the top altogether. You see that? Is the bottom always positive? It is not. So we have to consider 1 and -1. And you can consider, I mean, x squared minus 1, it does just make a parabola, right? And so you can see that the parabola would be positive, negative, positive. If you wanted to test points, go ahead. So if you plugged in -2, you would get 4 minus 1 is 3 to the 3rd is positive. And if you were to test 0, it would be -1 cubed is -1, so negative, and then positive. So what does that tell us? Concave up from union with 1 to infinity. Concave down from -1 to 1. Inflection, is there inflection? It changes from positive to negative, negative to positive. They're not in the domain. So remember, inflection is a point. And so you need to be able to come up with a y value. And you can't come up with a y value because if you plug in -1 or +1, the function is undefined as those we already determined. It is not part of the domain. We have all these beautiful pieces. Let's do the most exciting thing, which is to sketch the graph. Yeah! Okay. Now, yesterday I got a B from KLE, right? And then you gave me an A, but I don't think you really wanted to give me an A. I think you just felt bad for me. You gave me out of pity. And I don't like that. I want a real grade, okay? All right, so here we go. I got my game face on. I'm going to go a 6x6 graph. That's what I'm going to do. 1, 2, 3, 4, 5, 6. Whoop, looks like I went 8. 1, 2. No, I can go 8. It's math teacher's prerogative to change his mind. I was thinking of something. I heard something on the news today that today was like the anniversary of the date that prohibition ended. We should all get drunk. Uh, yes, yes. Foreign presidents' funerals going on. No, what I was thinking was that shortly after that, women's suffrage passed, right? I, okay. I wonder if those were connected. You know what I mean? Because part of the reason why prohibition started in the first place was, I mean, yeah, I mean there was a lot of problems happening in homes. I mean there was a large outcry from the women population, right? So anyway, it would be something interesting to do a paper on if you were looking for a paper for a history class or something. That was like one of the worst ideas I've ever heard in my life. Unless it was like a history paper of math, unless we were gonna do it like on like Archimedes or something maybe. But okay, all right, okay, let's go. And behavior, y is equal to 2. Yes, President Bush passed away. His wife passed away a few months ago. Um, Definitely a time where you set aside politics, whatever your feeling is on certain sides of the aisle. He was a very good man, somebody you can be very proud of. So neat guy. We all okay with that? So I've got the intercepts of 0, 0. So I know it. I really just know one point that it goes through. What do I know about the function between -1 and 1? Concave down, and it goes from increasing to decreasing, right? So it says it's concave down between -1 and 1. And it says that there's a local max there. And it says it goes increasing -1 to 0 and then decreasing 0 to 1. See all those pieces? It's kind of cool. So tell me something about the function from -infinity to -1. It's increasing and it's concave up. So if it's increasing concave up, is it going to be in the top or bottom? It's going to be in the top. Well, it says it's increasing from negative infinity to negative 1. So increase would be like that. If it was below, it would be decreasing, right? Furthermore, it says it's concave up, so it's holding water. So concave up from negative infinity to negative 1. Yeah, from negative 1 to 0, it's on its way up. Then from 0 to 1, it's on its way down. Increasing, decreasing, concave down the entire time. Those are the two pieces. The last one, okay, from 1 to infinity. 1 to infinity, it is decreasing and, so is it going to be in the top or the bottom? Which is it? It's in the top. It's decreasing. If it was going like this, that would be increasing. Going like this is decreasing. And you can see that that is concave up. Oh boy. Now I get the grade. Kelly, are you ready? You ready to judge my work? I want a grade. Window, -8, 8. That's it. Last time I had electrical inspection done, I told the guy, I said, hey, I said, I'm a teacher. I want a grade. And he looked like he was going to hurt my feelings. I said, hey, I can handle it. If I deserve a D, give me a D, man. He said, no, I give you about a B plus. I said, okay, that's all right. That's okay. Ooh, I don't like that. And I said, do you want a grade on how well you clean my teeth? All right, here we go. You ready? Good point. Whoa. I know that. Oh, what could I do to be better? It seems. Oh, man. Mm. I'm going to blame it on the calculator. Not enough pixels. Not enough pixels on the calculator. Is that better? Wow. You guys are a tough crowd. All right. That's it. You're done with the unit.